Mr. Lichty here. We are going to start with 5.1, Operations with Polynomials. Remember that each time we start a new section, start by writing the title in your notebook along with the date. I'll give you a second to do that. Today is April 5th. All right, the first thing we're going to start with in this unit is we're going to start with some background information about exponents. Yay, exponents. So, remember that an exponent refers to how many times to multiply the base by itself. Okay? So, for example, if I take 3 and I take that to an exponent of 4, we say 3 to the 4th power. This is the base. This little guy is the exponent. Okay? So what this means to do is to take the base 3 times itself 4 times. That's what an exponent means. We could multiply that out if we wanted to. Okay? So, something important to remember in this unit. Always remember that exponents are only attached to one thing. It could be a chunky thing with parentheses, so here's what I mean by that. So, in this case, if I have 2x plus 1 in parentheses to the 2nd power, this whole thing, since there are parentheses and there's a 2 outside of it, this whole thing is being multiplied by itself 2 times. Okay? That's a little different than if I had 2x to the 3rd power. Okay? Now, this 3rd power, this exponent, is only attached to this x. So be careful. Exponents are only attached to one thing. So let me go through an example. So examples, if it says example, like this one here, if it says example, it's okay if you just watch the examples. You don't necessarily have to write them down. If you want to write them down in your notebook, you can, or like I said, you can just watch. I will give you some problems to try in your notebook. So if I want to expand this expression, I really have to be careful to see what the exponents are attached to. So this exponent of 2 is attached to this 2x. So what I need to do is I need to write 2x twice, because that exponent is attached to the whole thing. This exponent of 3 is attached to the y. So I need to write times y, times y, times y. If you want to put a little times between the 2 and the x, you can. So that's what I mean by completely expanding an expression. So when I look at this, I see 1, 2, 3, 4, 5, 6, 7 individual things being multiplied together. Now the second example, again, it's an example, so you can just watch if you want to, watch and listen. Again, be careful, because exponents are only attached to one thing. So, first thing I'm going to do, this 4 does not have an exponent, so I'm just going to bring it down. Now, this whole thing that's in parentheses has an exponent of 2. So I am literally going to copy this thing twice. 2a to the 3rd power times another 2a to the 3rd power. Again, I copied it down twice because there's an exponent of 2. Okay, next thing I'm going to do is I'm going to expand this one. This b has a power of 4, an exponent of 4 attached to it. So I'm going to write times b, times b, times b, times b. Now, it's not technically completely expanded yet because I still have exponents attached to these a's. So what I'm going to do is I'm going to go one more step. 4 times 2 times a times a times a times 2 times this one, a times a times a. I'm running out of room. Now the b's, times b times b times b times b. There. Now it is completely expanded. Okay, so completely expand each expression. I left one of the examples there for you. Make sure it's completely expanded. All right, take a second to do that on your own in your notebook. Okay, now that you've had a second to try those 3 on your own in your notebook, I'm going to go through them. So this first one we can do in one step. This base b is attached to this exponent 2, so I'm going to write b times b. This one is attached to the exponent 3, so that's x times x times x. And there's this b just sitting there that technically has an exponent of 1 because there's just one of them. And the last one, x, has an exponent of 2, so I'm going to write it twice. And there's my answer completely expanded. Okay, the next problem is going to take me 2 steps because it's a chunk. So first, this whole thing is attached to this exponent of 3. So I need to write this whole thing 3 times. So just copy it down 3 times. 4x squared y cubed times 4x squared y cubed times 4x squared y cubed. So now I'm going to finish expanding that one, and I'm going to write 4 times x times x times y times y times y times another 4 times x times x times y times y times y, and I ran out of room, times another 4 times x times x times y times y times y. Yay! Completely expanded, so this would be my answer. Okay, now the last one, again, since it has some chunks, I am going to take it in 2 steps. Okay, so first, this chunk here is attached to the exponent of 2. So I'm just honestly going to copy it down twice. Negative 3a times negative 3a. Okay, this next one, this whole thing is attached to this exponent of 2, so I'm going to copy it down twice. 2ab squared times another 2ab squared, 2 times. So now I'm going to finish expanding, so negative 3 times a times negative 3 times a times 2 times a times, there's 2 of those, b times b times 2 times a times 2 of those, b times b. There we go, completely expanded. So there's my answer, completely expanded. Remember that if you have any questions throughout any of these videos, write down the question. So for example, if you have a question somewhere in this problem 3, write down, like, work the problem out, and then kind of write down your question in your notebook, like right underneath it. That way during office hours you can ask your question. So another example here. So if I look back at this problem that I already expanded, now the instructions say simplify it, which means put it back together. So here's what I can do. I can multiply the things that I guess are kind of alike. So I can multiply these 2 numbers. 2 times 2. Well, 2 times 2 is 4. I can multiply these 2 x's together and write it as x squared because there are 2 of them. And since there are 3 y's, they're the same. I can put them together. Y cubed. So putting it back together, I get 4x squared y cubed. Okay, moving on to example 4. So this is an example we already looked at. We already expanded it and got this whole thing. Okay, so now let's actually multiply the things that we can kind of put together. So if I do 4 times 2, that's going to give me 8. And then I can take that 8 times this 2. So that's going to give me 16. I can put all of these a's together. Okay, so a times a times a times a times a times a. That's going to be a to the 6th. And b times b times b times b is going to be b to the 4th. So my final simplified answer on this one is 16 times a to the 6th power times b to the 4th power. Okay, now I want you to look back at the 3 problems that you already expanded. I have them written down here, and I want you to take a minute on your own in your notebook to put these back together. Okay, so let me just quick go through these. So I'll start with the b's on this first one. I have b times b times b, so I can write that as b to the 3rd power. And I have x times x times x times x times x, so I can write that as x to the 5th power. So my final answer is b to the 3rd power times x to the 5th power. Number 2, I can multiply these 4's together to get 4 times 4, which is 16, times another 4, which is 64. So 64, I have x times x times x times x times x times x, so that's going to be x to the 6th power. 6 of them are being multiplied together. And I have y times 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 y. There's a total of 9 of those, so I can write times y to the 9th power. So my final answer is 64 times x to the 6th power times y to the 9th power. And the last one, careful with the negatives. I can do negative 3 times negative 3 and get 9. 9 times 2 is 18. 18 times 2 is 36. And I have 1, 2, 3, 4 a's, so that's going to be a to the 4th power. And I have 1, 2, 3, 4 b's multiplied together, so that's going to be b to the 4th power. So my final answer is 36 times a to the 4th power times b to the 4th power. Okay, so a couple problems I want you to try on your own. Take a minute to do that, and once you finish them, check back in for the answers. All right, welcome back. So first, let's look at number 4. Okay, when I expand it, I get this, 6 times n times n times n times 2 times n times n times n times n. Multiply the 6 and the 2 together to get 12. And your final answer is 12 times n to the 7th power. Number 5. Once I expand this, I'm going to have what I have there. And then now once I multiply things back together, 3 times 3 times 3 is 27. A times a times a is a to the 3rd power, and I have 6 b's multiplied together. So my final answer is 27a to the 3rd power times b to the 6th power. Again, if you're making any mistakes here and you're confused, please write down the question in your notebook right next to the problem, so that way during office hours you can say, hey, I had a question on this problem, could we quick go over it and you explain it? Okay, I want you to try these 2 problems on your own. Take a second to do so. All right, welcome back. Let's quick go through these 2 answers. Oh, sorry about that. All right, let's look at this first one. So if I completely expand this first one, I'm going to get negative 2 times x times x times y times y times y times another negative 2 times x times y times y times y times 3 times x times y times another 3 times x times y. Okay, so multiplying the numbers back together, I'm going to get negative 2 times negative 2, which is 4, 4 times 3, which is 12, and 12 times 3, which is 36. And if I count up all my x's, I have 6 of them being multiplied together, so that's x to the 6th. And my y's, I believe I have 8 of them, so times y to the 8th. Okay, the second problem, a little different. It's a division problem, it's a fraction, so let's expand it first and see what happens. So if I expand it, I'm going to get 3 times x times y times y times x times y on top. And on bottom, I'm going to get 3 times x times y times y times y times another 3 times x times y times y times y. Okay, I can go through here and cancel like things on the top and bottom. So 3 divided by 3 is just 1. X divided by x is just 1. This x can cancel with that one. This y to that one. This y with that one. Just be careful. It takes a little organization to keep track. Alright, so now left over, I'll just write what's left over on top. Looks like I have x squared on top, and on bottom I have 3y squared. So that is my final answer, x squared divided by 3y squared. So, while going over some of those examples and practice problems, some of you were probably like, well, hey, Mr. Lichty, there are shortcuts. We can take some shortcuts. Yes, you're absolutely right. But you can always refer back to kind of that basic definition of what an exponent means if you ever get confused. But now let's go over the shortcuts. So when you multiply same bases with exponents, for example, like a to the b power times a to the c power, what do we do with those exponents? Well, you can just make up a silly example here, like a squared times a cubed. I just put two numbers in for b and c. Well, if I use my basic definition, this is a times a times a times a times a, which is a to the 5th. Well, what did you do with the 2 and the 3? We added them. So yeah, so this is a to the b plus c. So when you multiply same bases, you add the exponents. Okay, what about dividing? Well, these bases, again, it's important to note, these bases are the same, a and a. Okay, so, well, let's make up another silly little problem, like a to the 5th power divided by a to the 3rd power. Okay, so if I expand that using my basic definition of exponents, I have a times a times a times a times a on top, divided by a times a times a on bottom. And in a fraction, when they're all multiplied together, we can start canceling same things. Boom, boom, cancel, 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 cancel. And I'm left with a squared. Well, what did we do? All we did was 5 minus 3. So the rule here is a to the b minus c. When we divide same bases, you just subtract the exponents. Here's how I say this one. Taking stuff with an exponent to another exponent. Again, silly example, a squared to the 3rd power. Okay, that's going to be a squared 3 times, because that 3rd power is attached to this whole thing, which is going to make this a times a times a times a times another a times a. Well, put that back together, that's a to the 6th. So what did we do with these two exponents? We multiplied them. It's kind of like we have 3 groups of a squared. And because I said groups, that kind of means multiply. So this is a to the b times c. So exponent to an exponent is called the power rule. We multiply those two exponents together. All right, let's summarize these rules, and I'm going to add a couple others. So a quick summary that you might want to jot down is when we take same bases, that's where we add the exponents, a to the m plus n. When we divide bases that are the same, we subtract the exponents. The answer is just going to be a, the base, to the m minus n. Exponent to exponent, that's that power rule where we just multiply the two exponents. Okay, a couple other rules that you might want to be aware of, and this can also be explained by the basic definition of exponents, is when we have two things multiplied together in parentheses, you can kind of apply the exponent m to each one separately. A to the m times b to the m. And the last rule, similar to the one above, except it's division. You can kind of just apply the exponent m to each of them separately. A to the m divided by b to the m. So right now might be a good kind of time to maybe take a quick break. This is just kind of a good stopping point for a few minutes before we move on with the next section. Okay, to kind of get into the next couple of rules, we're going to start by looking at this table, just an input-output table. I want you to actually jot this table down in your notebook. You don't need to make it all fancy, just a T chart will do. Copy these inputs down. Take a second to do that. So you're copying this table down. If you need more time to push, you can always push pause. So we're going to look at this. We're going to complete this table using this equation: y equals 2 to the n power. So we're just plugging in a different n each time we move down the table. So I started the first one for you. Okay. So the first one we're plugging 6 in for n. So that's why this becomes y equals 2 to the 6, which is 2 times 2 times 2 times 2 times 2 times 2. Multiplying that out, you get 64. Okay? The next one is going to be y equals 2 to the 5th power. So that's going to be 2 times 2 times 2 times 2 times 2. Writing it out this way, you can see that I'm multiplying by 1 less 2, which means that this is just going to be 32. Okay? Next one's going to be 2 to the 4th power. 2 times 2 times 2 times 2 is 16. Next one is 2 to the 3rd power. That's going to be 2 times 2 is 4 times another 2 is 8. 2 to the 2nd power, which is just 2 times 2, that's just 4. 2 to the 1st power is just 2. 2 to the 0th power, that just sounds weird. 2 to the 0th power? I'm confused. Okay, so to do this, let's take a look at, so in my inputs I see a clear pattern. It's going down by 1 each time, right? Do you see a clear pattern in the outputs? Well, yeah, what's happening in the outputs each time? Well, each time, since we're multiplying by 1 less 2, it's like we're dividing by 2. Therefore, if a pattern's established in both the inputs and outputs, the pattern kind of has to continue. So, that means, 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. Well, 2 divided by 2, so 2 to the 0th power has to be 1. And then 1 divided by 2. So 2 to the negative 1st power has to be 1/2. And 2 to the negative 2nd power, divide that by 2, that's going to be 1, has to be 1 over 4, 1/4. And 2 to the negative 3rd power has to be 1/4 divided by 2 is 1/8. Interesting. So that kind of tells us what 0 as an exponent does and what negative exponents do. I'm going to summarize on the next page. It's interesting here too because it wouldn't matter what the base is. We can change the base to 3. Okay? 3 to the 0th power is still going to be 1. We can change the base to 4. So let's summarize this on the next page. All right, so 0 as an exponent. Well, I think we just found out that whenever I take anything to the 0 power, I'm always going to get 1. Anything. So 3 to the 0th power. Yep, that equals 1. 5,261 to the 0th power. Yep, that equals 1. 2x plus 5 to the 0th power. Yep, that equals 1. So anything to the 0 power is going to be 1. All right, negatives as exponents. Well, from the table, we kind of saw that negatives as exponent, it doesn't give you a negative number, it reciprocates the base, reciprocates. So in other words, if I look at a, so a can be written as a over 1, and since a over 1 is attached to the negative, to take care of the negative, I can just write it, I can reciprocate, I can flip it, 1 over a. The 2 is still there, I literally just took care of the negative. And then if I multiply that out, well, actually, we'll just leave it there for now, just for now. So that's what a negative exponent does. Okay, so if we add a couple rules to our table, we already buzzed through these. I'll just put these up again. Boom, boom, boom. All right, so if we add a few rules to our table, okay, so this one's kind of a weird one. Okay, the bottom has a negative exponent. Well, honestly, that's just going to flip it back to normal and take care of the negative. Okay. I like this visual here. If you have a fraction, something divided by something else, in this case x over y, and the whole fraction is being taken to a negative exponent, the negative part literally just reciprocates. It flips the fraction. So you can write it as y over x. Now the exponent's not negative, it's just to the m power. And the last, well, not quite, anything to the 0th power is 1. Hopefully we got that in our heads. And this one we covered on the last slide. It's just going to reciprocate the a to 1 over a. Okay, so these are pretty much all of the rules that we're going to use throughout this unit. So next we're going to go through several example problems. I'm going to have you try several of them on your own. So take a second, try these two on your own. You don't have to expand anymore. Unless you thought that was really easy, then just keep doing it. Okay? But you can use the rules here. Okay, now that you had a chance to do those two, let me quick go through. This is an exponent to an exponent, so I'm going to take the 2 and times it by the 3, and that's going to give me x to the 6th power. Boom. These two is being multiplied, and the bases are the same. So this is really x times x times x times x times x times x. Yeah. There's going to be 12 of them, so it's going to be x to the 12th power. We add the two exponents. Boom. All right, next two problems. Try these two in your notebook on your own. Okay, number 10, again, the bases are the same, so being multiplied, so we add the exponent. So this is x to the 6th power. Done. This one, the bases are the same and we're dividing, so we subtract the exponent, 6 minus 4, and we get x squared. Done. All right, 12 and 13, try these two in your notebook on your own. All right, so I'm just going to apply this 3 to both things. Now, I'm going to do a little expanding on number 12. So I'm going to have y cubed on top, but the bottom is 2x times 2x times 2x. There's 3 of them down there. So that's going to be y cubed divided by 8x cubed. There's my final answer. So I took that one, I did a little expanding. I call that partially expanding to help me figure that problem out. Number 13, be careful. This negative 3 is only attached to the x. Exponents are only attached to one thing. So I'm going to rewrite this one as 3 times reciprocate it because it has a negative exponent, 1 over x to the third power. All right, so I'm going to simplify this problem. I'm going to write this as 3 over 1. So 3 over 1, I am going to expand this 1 over x just because I think it helps get a good visual here. All right, so now I can put everything back together. On top, I have 3 times 1 times 1 times 1, which is 3. On bottom, I have 1 times x times x times x, which is x cubed. There is my final answer. Okay, take a second to try these two on your own. All right, so number 14, dividing. So this one's kind of interesting. You can really just do the 4 minus 6 and get x to the negative second power, except in order to be completely simplified, and I want you to listen carefully, you can't have a negative exponent in the problem. So basically we just need to fix that negative exponent. So the negative just reciprocates this, so it's actually 1 over x squared, which is just 1 over x times 1 over x, which is 1 over x squared. Done. You know, another way you can actually think about this is if you just expanded the original problem. You have x times x times x times x on top. You have x times x times x times x times x times x on bottom. I mean, take a look. Cancel, 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 cancel. What's left on top? 1. So that would just give you 1 over x squared. So the expanding there is pretty simple to see. All right, number 15. You know what? I'm going to at least partially expand this one. I'm just going to write 4x cubed 4 times. Yeah, it takes, about 5 seconds, but I think it makes it pretty easy to visualize what the answer is going to be. So that's going to be 4 times 4 is 16, times another 4 is 64, times another 4, I'm going to just go to my calculator here, is 256. And I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be x to the 12th power. There's my final answer for 15. You notice that the problems are getting a little more challenging, and they're going to continue to do so. So if you have questions, please just write the question down right next to the problem you had a question on. And during office hours, you can ask that specific question. Okay, try these 2 problems on your own. Okay, problem 16. So same bases, dividing, so you can easily just subtract the exponents. A little weird, I'm going to write it out. -2 minus -5. So that's going to be -2 plus 5, which is just going to be 3. So my answer is just going to be x to the 3rd power. That actually worked out kind of nice. Okay. The next one, I'm going to write this one out a few times. I'm going to add a 1 in here, though. That's technically -1 times y squared. So I'm going to write that out 5 times because it has a 5th power to it. So -1 y squared times -1 y squared times -1 y squared, yada yada yada. You get real annoyed with me saying the same thing over and over, huh? So 5 times. 1, 2, 3, 4, 5. So the reason I did that is I wanted to kind of get a visual. So -1 times -1 is positive, times -1 is negative, times -1 is positive. Okay, so it's going to be -1, and I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be -1 times y to the 10th. Is my final answer. Okay, 18, 19. Try these 2 on your own. Again, it might really help to expand them. I'm going to show you maybe a little trick here and there, so try them on your own. Okay, let's take a look at 18. So problem 18, I am going to, I'm going to at least partially kind of expand these. So this is going to be jk squared twice times another jk squared divided by, I'm going to write this thing 3 times, and I'll put it back together here in a second. So j to the negative 1k times j to the negative first times k times j to the negative first times k. All right, so putting things back together and kind of reorganizing, I'm going to have j squared times k to the fourth on top over j to the negative third times k to the third power on bottom. Okay, now I can subtract kind of separately. So I'm going to do 2 minus negative 3 for this one. That's going to plus plus, that's going to be 5. Okay, that worked out nice. And 4 minus 3 for that one, that's going to be 1. So my final answer is going to be j to the 5th power times just k. Done. That worked out nice. Okay. This next one, again, I'm going to partially expand this. Actually, I use the power rule. So I'm going to kind of give this exponent to both the top and the bottom here. So a squared cubed, exponent to exponent, I'm going to multiply. So that's a to the 6th. And then another one, exponent to exponent, negative 3 times 3, that's going to be b to the negative 9. So the issue here is I have a negative exponent, and I can't have that as in my final answer in order for it to be completely simplified. So if you have a negative exponent in a fraction, this is something cool you can do. This thing has a negative exponent and it's on the bottom. Well, to reciprocate it, literally just move it to the top. So my final answer is a to the 6th, b to the 9th. Again, the negative exponent, since you moved it, is now positive. Boom, there's my answer. Okay, 20 and 21, take a second to try it on your own. You can use that last rule that I just talked about with number 20, where you can just kind of move things that have negative exponents and then simplify. Okay, so I'm going to try that kind of little shortcut that I just explained. So this x has a negative exponent, so I am going to move this thing down. This y has a negative exponent, so I'm going to move this thing up. Okay, so I'm going to rewrite. So I have the 4 is still on top, the y cubed is still on top, and this y to the 6th is positive now. I moved to the top and made it positive. 32 is still on the bottom, x to the 5th is still on the bottom, and this, which had a negative exponent, I'm going to move down, is now x squared on bottom. Alright, so now things are kind of nice. Now I can kind of just simplify. First thing, I can actually reduce both those numbers by 4. So 4 goes into this once, 4 goes into this 8 times. And then I can put the y's together. So on top, I have 1 y to the 9th. Or I can just write y to the 9th is fine. And on bottom, I have 8 x to the 7th. And that's my final answer. That actually worked out kind of nice. Alright, next one, nice. No negative exponent. So just multiplying fractions is easy. Just multiply the tops. That's going to be 2x times x times x is x cubed times y. On bottom, just multiply the bottoms. I have 4 times y cubed. But now I need to simplify. Okay? So I can reduce 2 over 4 to 1 over 2. If you expanded these y's, you'd have 2 extras on bottom. So the one on top is going to cancel, and you're going to have 2 left over on bottom. So your final answer for this problem is just going to be 1x cubed on top divided by 2y squared on bottom. If you want to expand this and then cancel things out, that might make it easier to see, but you're still going to end up with this answer. All right, try 22 and 23 on your own. Again, they're getting a little more challenging, but you can do this. You just have to, be very careful in this unit. And remember that exponents are only attached to one thing. Okay, so let's take a look at 22. I'm going to do a couple things at once. So first I'm going to simplify the top actually. So 5 times negative 2, that's going to be negative 10. I can add the 2 and the negative 1, so that's just going to be x to the first power. That worked out nice. And then y times y is y squared. Okay, that's the top. The bottom, just multiply the bottoms together. You get 8x cubed y. All right, so if you expanded this, yeah, nice things, you'll see that some things cancel. So this part, the numbers, I can reduce both those by 2, so that's going to become negative 5, and this is going to become 4. The top x is going to cancel with one of these x's on the bottom, and the bottom, this y is going to cancel with one of those y's. So my final answer is negative 5y over 4x squared. Again, if you expand this, it might be an easier visual for you. All right, next problem. I am going to flip and expand this thing. So because there's a negative exponent, I'm just going to flip this fraction, literally just flip it. 2x to the 4th over x cubed y squared. And since it's squared, I am actually going to write it twice, just so I can see it. 2x to the 4th over x cubed y squared. So not only did I take care of the negative by flipping it, reciprocating it, but I took care of the 2 by writing it twice. Okay, so now I'm going to multiply the tops together. That's going to give me 4x to the 8th. And simplify the tops, or the bottoms, that's going to be x to the 6th, y to the 4th. Some things cancel out with the x's. All of those cancel, and I'm left with 2. So my final answer is 4x squared over y to the 4th. Okay, little change of pace. Try 24 and 25 on your own. 24 is kind of multiply. 25 is really just combining like terms because it's a subtraction problem. Now 24, since there are no exponents on the outside of the parentheses, you can kind of just drop the parentheses here. So I'm just going to kind of look at it as if they're not there. So I'm going to do 2 times 3 to get 6. And, no other numbers. So 6. And then the rule with same bases, I'm going to add those two exponents, negative 2 plus 3. And that's just a to the first power. Nice. And then b squared is just b squared. And c to the negative 2. Now the issue with this right now is that I have a negative exponent on that c. What you can do to fix it, which you have to fix it in order for it to be simplified, you need to rewrite it. So the 6ab squared stays on top, and we just drop the c squared to the bottom to take care of that negative exponent. Boom, there's my final answer. 25, just a subtraction problem, okay? So it's really, I'm going to rewrite it without the parentheses, but you got to subtract these things. So this is just 4x squared minus 5x plus 6 minus 3x minus negative 1. So be careful, that's plus 1. Combine like terms, I have 4x squared, those two, minus 8x plus 7. No other like terms, that's my final answer. Okay, try these two problems on your own. All right, so 26, it is just an addition problem, so don't try doing anything crazy here. Okay, so it's really just combining like terms. So I can honestly drop the parentheses on this one. 6x to the fourth minus 7x plus 8 plus negative 4x cubed plus 9x minus 5. All right, combine like terms, and let's make sure it's in standard form, so highest exponent first. So 6x to the fourth, there are no more of those, so 6x to the fourth. Okay, that's going to be minus 4x cubed. There are no other x cubed, so minus 4x cubed. I have minus 7x plus 9x, so that's going to be plus 2x. And I have plus 8 minus 5, so that's going to be plus 3. There's my final answer. Really just a combined like term problem. All right, next problem. A little trickier on this one. It is multiply, so you actually have to distribute. They're right next to each other, so there's multiply. So you got to double distribute. So take the time. I'm going to draw the lines. So x times x squared, it's x cubed. X times 4x, that's plus 4x squared. And x times positive 16 is plus 16x. Now I'm going to distribute the negative 4. Be careful because it's negative. That's negative 4 times x squared is minus 4x squared minus 16x, and negative 4 times 16 is minus 64. Okay, now you can combine like terms and have your final answer. So biggest exponent first, so x cubed. 4x squared minus 4x squared, that turns out nice, that goes away. Holy bucket, 16x minus 16x, that goes away, and I'm literally left with just minus 64. So x cubed minus 64 is my final simplified answer. Okay, try number 28 on your own. Remember, you can only multiply two things at a time, so I'm going to multiply this thing by this thing first. Take a second to try it. Okay, so to multiply those two things, I do need to double distribute. So this is going to be 2a times 4a. It's 8a squared. 2a times b, that's plus 2ab. This is going to be negative b times 4a. That's going to be minus 4ab. And this is going to be negative b times b, which is minus b squared. I'm going to combine like terms. These are both AB, AB. So those are like terms. So I have, and let's put it in parentheses, 8a squared. Put those together. That's minus 2ab. And that's minus b squared. Now drop this third thing down that we haven't touched yet. All right, so this is going to be a little tricky, but just stay organized and you'll be fine. So I do need to kind of triple distribute here. So that's going to be 8a squared times 3b. That's going to be 24a squared b. Multiply those two. 8a squared times negative 5. That's going to be negative 40a squared. Now the next thing, negative 2ab times 3b. That's going to be minus 6ab squared. And negative 2ab times negative 5. Be careful with the signs. That's going to change to a plus 10ab. Last thing to distribute is the negative b squared. Negative b squared times 3b is minus 3b cubed. And negative b times negative 5 is going to be plus 5b. All right, are there any like terms here? I have a squared b. Nope. I have a squared. Nope. I have ab squared. No like terms. I have ab. No. I have b cubed. No like terms. And I have just b. No, there are no like terms. So honestly, this is my final simplified answer. All right, 29. Take a second to try this one. Double distribute. Okay, so x cubed times x cubed is x to the 6th. Good thing we practiced our exponent rules. X cubed times y cubed, that's just going to be minus x cubed y cubed. Can't combine those. So then distribute this. That's going to be plus x cubed y cubed. And y cubed times negative y cubed, that's going to be negative y to the 6th. All right, these are like terms. I have 1x cubed y cubed here, and I have negative 1x cubed y cubed plus another 1x cubed y cubed. They cancel out. They're exact opposites. They cancel out. So my final answer is x to the 6th minus y to the 6th. One turned out nice. Actually, that was a difference of squares. Next problem. Ooh, looks complicated. Well, I am going to factor the GCF from the top and see if anything cancels. Okay, so if I just look at the top and look at, I'm going to find the GCF. So what's the greatest common factor that goes into those three numbers? 6. Okay, how many x's do they, so this one has 4, this one has 3, this one has 2, so the maximum amount that they all have is 2, so I can factor x squared from all of them. And then let's look at the y's. Okay, I have 3 on the first term, 2 on the second, 1 on the third, so I can really only take 1 out of all of them. So, and left over is 1x squared y squared, because I took one of the y's out, plus 2, 6 times 2 would be 12, x, because x squared times x would be x cubed, and y minus 3, minus 3, all divided by 3xy. Alright, so now that I have factored the top, I have it broken up into this factor times this big chunky factor is really just two things. I can actually cancel things that are common on top and bottom. So what I can do is 3 goes into both those. So I can change this to a 2, this to a 1. This x is going to cancel with one of these x's, and this y is going to cancel with this y. So my final answer, everything on the bottom canceled, so I just have 1 on the bottom. So my final answer is 2x times x squared y squared plus 2xy minus 3. You can multiply that 2x back in if you want, but I will totally accept this answer. Okay, problem 31. Similar to the last problem, try it on your own, and I'll come back and I'll go over it. Okay, we are going to factor the top. The bottom is just one thing, so we don't really need to do much with the bottom, but we're going to pull out the GCF, greatest common factor, of the top. So first I look at the numbers. The greatest common factor of those three numbers is 2. So I can pull out a 2. Then I'm going to look at the x's. So I have, this one just has a 1x, so I can just take 1x out of all of those. I'm going to look at the y's. Alright, this one only has 1, so I can only take 1 out of all of them. And then I'm going to look at the z's. Alright, this one only has 1. So I can only take 1 z out of all of them. Alright, so left over, I took 1x out, so x y squared plus 2x squared z cubed minus 4 times y z. Okay, all divided by 2x squared y squared z cubed. Alright, so the 2's can just cancel out. This x is going to cancel one of these, so I'm still going to have one of those. This y is going to cancel one of these, so I'm still going to have one of those. And this z is going to cancel one of these, so I'm actually going to have two of those. So that worked out kind of nice. This whole thing canceled out. So I have left on top is just this factor, xy squared plus 2x squared z cubed minus 4yz, all divided by, left over on bottom, I have x, y, z squared. There we go. Okay, that does it for the notes on this section. Just take your time, really listen to the notes, take good notes, write down questions as they come, and you'll do great. So there is a practice, there are practice problems for this section, so please do the practice problems in your notebook.